Okay, so going over a quick review of what we did yesterday, we have a problem with a power rule for the first one, and remember the reverse power rule is to add 1 to the exponent and then divide by the new exponent. So for each of these you have 2 terms, integrate them separately. So for this one you get x, it was to the first power, so to the second, and when you divide by 2, that coefficient of 2 will cancel. Secondly, you've got x cubed, again, divided by 3, and the coefficient of 3 will cancel, and don't forget your plus c. That's using the reverse power rule. The other rule we'll need for today is with trig functions, and I gave you this handy-dandy whose derivative is that. So for cosine, whose derivative is cosine? Sine x. So bring down the 5 because it's a coefficient, just like with derivatives, and you would write sine x here because sine x's derivative would be cosine. And then same thing with the next term. This one would be negative cosine. So bring down the coefficient of 4 with the negative out front, and don't forget your plus c. So those are just some skills that you might need for today. What we're talking about today is something called simple substitution, and actually I would call this u substitution. We use the variable u to do some substitutions, and simple will actually, I'll explain why they call it that in just a minute. So if you look at our example here, you'll see that this is not just a simple power rule. This is actually a product and a chain. So when you see a product, quotient, or chain, as explained yesterday, there is no product, quotient, or chain rule with integration. What we have is something called u substitution. And what you do, and it's going to need to take a couple examples to kind of get this right, but what you do is you pick a u, something, whose derivative is in the problem. So pick something whose derivative is in the problem. So the u, or the thing I'm going to pick, is 3x cubed plus 2. Because when you take the derivative of that, you get a 9x squared. So if I go through and go ahead and take the derivative of both sides, the derivative of u with respect to x is this. And on the right side, you get 9x squared. So this next part you might not understand but right away, but what we do is you keep your u's on one side and your x's on the other. So du equals 9x squared. I'm going to multiply my dx over, so it's over here. And there's a reason for all this. So the 9x squared dx is right here in our problem. And what we're going to do is substitute that out. So 9x squared dx actually comes out, and I'm just going to write du in. And the 3x cubed plus 2 comes out, and I'm going to write u instead. And don't forget that's squared. So now we have a much simpler problem. This is hence why they call it simple substitution. But go ahead and integrate now our new problem. It's all in terms of u, and it's just a simple power rule. So the integration of u squared would be u cubed over 3 plus c. And then we simply don't want u in our answer, so we plug u back in. So 3x cubed plus 2 quantity cubed over 3 plus c is our final answer. And that's your first example with u substitution. And the reason why we do u substitution here is because this is a product and a chain rule. So this is the rule for product, quotient, and chain rules. Below is a kind of a theorem, the theorem for u substitution. It's a bit complicated, a little bit messy, but basically it kind of looks like a chain rule. But we also use it with product and quotient. So let's move on to some more examples. So here is guidelines that I've given you. Sometimes picking u isn't easy. Knowing what thing to pick. So here are a couple guidelines, and first thing I would say is, like I told you earlier, pick a u whose derivative is in the problem. That'll always be helpful. But another helpful tip is usually it's best to choose the innermost part of the function. So something that's on the inside, call that your u. Second step is you find du. Third step is you write the integral in terms of u. Then integrate our new simple function. And once you get an answer, plug u back in so that we're back in terms of x. Couple cool things is you actually can take the derivative of your answer to see if it is the question, so that you'll know that if you did it right. And don't forget that we're doing integrating indefinitely, so we always need a plus C. So here's some steps and some guidelines of how to pick U and what actually to do, the step-by-step process. Don't forget, you can pause this video at any time to get caught up on the notes. So let's do an example. So first, looking at this problem, you'd think, okay, this is just like what we did yesterday or in the warm-up here, but it is a little different because this is a chain rule. You got the cosine of 5x, not just the cosine of x. So you need to pick a U. And it's nice with our little guidelines here, they say usually it's best to pick the innermost part of the function, so it kind of helps us that we should pick 5x as our U. And as I stated earlier, du should be in the problem. So the derivative of 5x is 5, which happens to be in the problem. And then don't forget, we want to separate our u's and x's. So du on this side and 5 dx on this side. In the future, I'm just going to actually always write dx on the right side, kind of skip that step, but that's where it comes from. So rewrite now, sorry, we kind of going through our list, we found du. Now we're going to rewrite the integral in terms of u. So 5 and dx is actually going to come out, and that's our du, so integration. And I usually write du off to the side. And then this u is 5x, so that means right here, that's our u. So we have the cosine of u. So just swapping things out, substituting things out. So that's rewritten in terms of u. Next, it says integrate this. So whose derivative is cosine? We're using that technique here, and that would be sine of u plus c. So you've integrated using the technique with the box, and now you want to replace u back in. So take u, plug it in here, and you have the sine of 5x plus c. And that is our answer. Now, if you wanted to check this, you could take the derivative of it, and that's a chain rule. So the derivative of the outside, leave the inside, times derivative of the inside, and that's actually our problem. That's what we started with, so you know that this is correct. All right, moving on to the next problem. Here are a couple more. We'll stop here after these two. You can see that this example that we're working on now is a product and a chain rule. So definitely going to require u substitution here, not just a power rule. U would be x squared. Then if you take the derivative, you're going to have du on this side and 2x, and again, I'm going to multiply my dx over at the same step, saving myself some time. Now, this looks pretty good. I've got my u, and I have an x dx, but my du is 2x dx, so I can't simply substitute them out because they're not equal at the moment. So this happens quite a bit, and if you have an extra number, like this 2 right here, what we have to do is divide it over. So if you divided that 2 over, you'd have this. And now, x dx can substitute out because I know what it equals. It equals 1/2 du. So in rewriting my integral, I always write du off to the side here, and 1/2 is a coefficient, so you can actually take that out front. And then u is this x squared, so I have the sine of u. And again, this problem looks much simpler once you substitute everything out. Do our box technique, whose derivative is sine of u, and that would be negative cosine of u. And don't forget, plus c. And don't forget you have this 1/2 coefficient, so what I'm going to do is move the negative over and put my half there. And now I just have to plug my u back in. So negative 1/2 cosine of x squared plus c. Final answer. All right, last problem for the day. So this one's just a big mess. Obvious chain rule here, and also a product. So pick the u, and again, the easy u is to pick the one on the inside. Often helps. The derivative of that, again, is 2x dx. Same as the last problem. I don't have a 2x dx, I just have an x dx. So again, coefficients can be divided over. And when you substitute all that in, the 1/2 is a coefficient, so I leave it on the outside. du, I always write off to the right. And this whole piece is u. So I really have the square root of u. So problem looks a lot nicer. And again, when we took derivatives with radicals, we always rewrote them. So this is really u to the 1/2 power. So when we integrate that, it becomes u to the 3/2. And instead of dividing by 3/2, because power rule says you add 1 and then divide by the new exponent, well, I'm going to multiply by 2/3 instead, and then bring down my 1/2. And I got my plus c. So looks like a big mess, but nice to know that fractions just multiply straight across. So really you have 2/6 there, or 1/3. U to the 3/2 plus c. And then finally I'm just going to plug my u back in. So I've got 1/3 x squared plus 1 to the 3/2 plus c as my final answer. All right, guys, I hope this helped. Let me know if you have questions. You can text on Remind. Go ahead and start the worksheet for today, and hopefully this was okay. Feel free to rewatch it.